Hello students, in the previous video we discussed about some of the examples on the properties of Z transform. That means we took some examples on how the properties of Z transform can be used to find the Z transform of the given signal. Now in this video we are moving to the next topic, that is inverse Z transform. Now this inverse Z transform, this can be found by two methods. So these are not the only methods that are available. Here we are using these two methods which can be used to find the inverse Z transform. The first one is by partial fraction expansion. Partial fraction expansion method, and the second one is power series expansion method. So these are the two methods which can be used to find the inverse Z transform. Now we'll start with the first one, that is partial fraction expansion method. Now the partial fraction expansion is given in this form. That means x of z will be given. You have to find x of n here. Now while applying this, you need to remember some standard z transform of that. That means you have to remember the z transform of the signal like alpha n into u of n. Okay, and you have to remember the region of convergence. We have solved some of them, like z transform of alpha n into u of n, z transform of u of n, z transform of delta n, z transform of n into x of n, z transform of n square into x of n, and so on. Now these are some of the standard methods which we have solved, which we can solve using a z transform. We usually encounter with these kind of uh, Z transforms, and we have to remember the inverse of it. That means for Z transform of alpha n into of n, it is 1 divided by 1 minus alpha Z inverse, where Z is greater than alpha. Suppose if this alpha n is a negative time sequence, then you will get the same Z transform, 1 divided by 1 minus alpha Z inverse, but the ROC will be inside that alpha, where that is Z is less than alpha. So that is for the same problem, if it is positive time sequence or negative time sequence, depending on that, you have to remember the things. Now in the problem, usually the Z transform will be given, that is x of z. For that, the ROC will also be mentioned. Now based on this ROC, we have to identify whether it is a left-sided sequence or right-sided sequence. In other words, we call them as positive time sequence or negative time sequence. Right-sided sequence is nothing but positive time sequence. Left-sided sequence is nothing but negative time sequence. Now, while applying that inverse transform, you have to remember these in the problem, whether it is right-sided or left-sided. Based on this only, we have to come to the final solution. Okay, now coming to the partial fraction expansion, so x of z will be in the form of b of z by a of z. So that means b of z will be here. We'll get this in the fraction form, where the numerator will be of this form. And the denominator will be of this form. So this is the expansion of this summation. If you observe this thing, uh, it is, what about in this one, the value of a naught is always equal to 1 here. Now to apply this partial fraction expansion, so usually your Z transform will be of this form, and if you observe the powers, m and n will give you the powers, the value of that. And to perform this partial fraction, to perform partial fraction expansion, so the value of m should be less than n. That means the numerator power should be less than the denominator power. If this doesn't happen, sometimes the power of numerator will be same as that of the denominator, or sometimes it might be greater than that of the denominator. In that case, we can't apply this partial fraction expansion. Now for that situation, we have a solution. So if this condition is not satisfied, if this condition is not satisfied, by using long division method, so we have to bring this x of z to this form. So to the form x of z is equal to summation k varying from minus infinity to, m minus n c k z to the power of minus k plus b bar z divided by a of z. So remember, this is b of z by a of z, and this one is b bar z by a of z. Now what is this b bar z? Now b bar z is the simplified version of x of z. That means the numerator has been brought to a form so that we can apply the partial fraction for this term, the second term. Now what about this first term? The first term will be the quotient. Now whatever you get this as a quotient, if you while using long division method, so you will divide b of z by a of z, and in that process whatever you get as a remainder, that will be b bar z, and what you get as quotient, that will be c k z to the power of minus k. Understood? Now this is using those quotient and remainder, we are going to express x of z into this form. Now you have to perform long division such till the power of the numerator becomes less than the denominator, or in other words, your divi your divisor power should be greater than the remainder. Okay, so when the remainder power becomes less than the divisor power, there you will stop that long division process, and we take the quotient and we place it here, plus the remainder will be written as b bar of z, that will be the new numerator, and this a of z will be the divisor. Now in this way, uh, it will satisfy the condition for applying the partial fraction, that is m less than n. Now we can apply the partial fraction for the second term. Okay, so this is the method. Now this partial fraction, you can go to the normally used method like a by denominator of the first term and b divided by denominator of the second term. You can use the notations a, b and all. And for there is another method for which is an alternative for this one. So that means if we have x of z, if x of z has poles at z is equal to psi l, which are distinct, and the value of L should be less than or equal to n, between 0 and n, comma, then the partial fraction is given by x of z is equal to summation L is equal to 1 to n k L divided by 1 minus psi L z inverse. Now what is this KL? Where KL is equal to 1 minus psi L z inverse into x of z, where z takes the value of psi L. So that means you will be expressing x of z in terms of partial fraction depending on the value of n, that is the power of denominator. Now we will get one or two unknowns to find. Now that will be expressed as k1 and k2. If you have three unknowns, it will be k3. Now whatever the denominator k1 has, so that will be written here, that and which is that will be multiplied by x of z, and the z value will take the value of psi L. That means whatever the quotient you have for z inverse, so that value will be applied to z here. Now substituting that value for z and simplifying, you will get the unknown value, whether it is k1, k2 and so on. Okay. Now to have a to understand these concepts, we'll take an example and apply this, and let's see how we are going to get the end result. Okay, so let's take some examples on this. So here it's given, find the discrete time sequence x of n which has z transform x of z is equal to minus 1 plus phi z inverse divided by 1 minus 3 by 2 z inverse plus 1 by 2 z to the power of minus 2, and the ROC is given as z greater than 1. By looking at the ROC, you can identify that it is a positive time sequence, because for positive time sequence only z will be greater than the circle, unit circle. Okay, here the value is 1. Sometimes it might be 1 by 2 or 2, 1 by 3, any value. Okay. Now looking at this x of z, if you see, we have z inverse is given, and below we have z to the power of minus 2. Now if you multiply this with the highest power, z square, both numerator and denominator, you will get z here and you will get z square here. That means the power of numerator is less than the denominator. So how we can write, x of z is equal to minus 1. Okay, I am not going to write that again, since we can see here only. I will directly start applying that one. Now if you observe this, we can see that m is less than n. So here m is less than 1. So we can apply partial fraction expansion. And this term, now you have, if you are applying the partial fraction expansion, it is mandatory that you have to find the factors of these two. Now for 1 minus 1 by 3 z inverse plus 1 by 2 z power minus 2. So you can find the factors in this way. If you multiply the last two term, you will get 1 by 2 z to the power of minus 2, and you should find the combination where if you add, you should get 1 by 3 minus 1 by 3 z inverse, and if you multiply, you should get 1 by 2 z inverse. So that kind of factors you have to find, which you get as 1 by 2 z inverse and z inverse. 1 by 2 into 1 will give you 1 by 2, z inverse into z inverse will give z power minus 2. But here to get this term, I will add minus and minus for both of them. So minus into minus get cancelled, that will give you the positive value, and if you add these two, you will get minus 1 by 3 z inverse. So this is the first game I'm explaining in detail. In the later problems, I'll just write down the factors. Okay, so based on this, we can write 1 minus 1 by 3 z inverse plus 1 by 2 z power minus 2. Now the factors are 1 minus 1 by 2 z inverse and 1 minus z inverse. These are the factors. Okay, so therefore we can write x of z as minus 1 plus 5 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus z inverse, where z is greater than 1. So using partial fraction expansion. So using partial fraction expansion, so you can write x of z is equal to, now observe this, these two, we leave the numerator, we take the numerator as the unknowns. I will write this as k1 divided by 1 minus 1 by 2 z inverse plus k2 divided by 1 minus z inverse. And if you come to this part here, you can see this KL divided by 1 minus psi L z inverse, where L is equal to 1 to n. And here if you observe, we have m is equal to 1 and n is equal to 2. So that's why you will have two unknowns. If you expand this, L is equal to 1 to 2, k1 by 1 minus psi L z inverse plus k2 divided by 1 minus psi L z inverse. Now that will be the second one, k2. This is the first one. So we have written the two factors here. Now we have to find k1 and k2. Just for reference, I am writing this kl is equal to, how to find this kl? 1 minus psi l z inverse into x of z, where z takes the value of psi l. Now based on this, we can find k1 is equal to, now what is the denominator of k1? We have 1 minus 1 by 2 z inverse into x of z. So just write this x of z here, minus 1 plus 5 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus z inverse. Okay. Now what value z will take? Z will take the value of psi l. Now psi l value, if you compare these two, the value is 1 by 2. So you can write that we have same minus and minus sign. So that's why in place of psi l we have 1 by 2. So z will take the value of that. Now these two get cancelled. So you'll remain with minus 1 plus 5 z inverse divided by 1 minus z inverse. So remember, we have to apply the value for z, not z inverse. If you do that, you will get minus 1 plus 5. Now z inverse is there. Now if you take the inverse of 1 by 2, you will get just 2 divided by 1 minus z inverse is there. Again it is 2. So that gives you 5 2 plus 2 as 10. 5 2 is 10 minus 1 is 9. And here in the denominator you will get minus 1. So the value for k1 is minus 9. So that is the first term. Going to the second one, k2. So k2, same thing we are going to repeat here. Now in place of 1 minus il z inverse, we have 1 minus z inverse. So that we will write here 1 minus z inverse into x of z. So x of z is minus 1 plus 5 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus z inverse, and z takes the value of psi l. Here in case it is 1. Okay. Now this and these two term cancel, so we will remain with minus 1 plus 5 z inverse divided by 1 minus 1 by 2 z inverse, where z takes the value 1 here. Now if you substitute that value for this term, I think I forgot to write z is equal to 1 by 2 here. Sorry, yes. If I substitute that value, so minus 1 plus the inverse of 1 is 1 only, divided by 1 minus 1 by 2 into 1. So that allows us 5 minus 1 is 4 divided by 1 by 2. So that gives us 8. So value for K2 is 8. So keep these values. So now substituting that, I think we should give a equation number here for this. Now substituting in equation 1, we have x of z is equal to minus 9 divided by 1 minus 1 by 2 z inverse plus 8 divided by 1 minus z inverse. So this is x of z here. Okay. Now if you move on to the further step, that is, we have to find the inverse of this. If you observe, ROC, that is z, is greater than 1. So therefore x of n is right sided or positive time sequence. Okay. And if you go to the standard deviation, alpha n into u of n will give the z transform of 1 divided by 1 minus alpha z inverse. Now if you just take u of n, the z transform of this will be 1 by 1 minus z inverse. Okay. So now based on this, if you take the inverse, if you compare these two, in place of alpha we have 1 by 2, and this one is 1 minus z inverse, we have 1 minus z inverse, same thing. So taking inverse z transform, taking inverse Z transform. So observe x of n is equal to inverse Z transform on both sides. So this x of z will become x of n, and we have minus 9. So we can write this here minus 9. So if you take minus 9 outside, this will become 1 divided by 1 by 1 minus 2 z inverse. So that will be alpha n into u of n. In place of alpha, we have 1 by 2 into u of n. Since this is a positive sign sequence, we are representing it as u of n plus 8 into, so another term, if you take 8 outside, you will remain with 1 by 1 minus z inverse. Now that is the z transform of u of n. So this is the inverse z transform of x of z. Or you can combine these two, like minus 9 into 1 by 2 to the power of n plus 8 into u of n. So this will be the final answer. Okay. Now I'll take one more example. Here it's a different approach. So let's see. So given using partial fraction expansion method, obtain time domain signal corresponding to the Z transform given below. So here we have x of z as 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus 1 by 4 z inverse. For this, we have three different ROCs here. The first one is for z greater than 1 by 2. Second one is z less than 1 by 4. And third one is z is between 1 by 2 and 1 by 4. Now we have to find the inverse Z transform for x of z for these three conditions A, B and C, which defines the ROC. So the first one, ROC is greater than 1 by 2, second one, ROC is less than 1 by 4, and in the third one, ROC is lying in between 1 by 4 and 1 by 2. So that if you makes the input signal slightly different one. Okay. So first we'll find, we apply the partial fraction expansion here. So given x of z is equal to 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse into 1 minus 1 by 4 z inverse. Okay. Now it's already in the split form, and you can see z inverse, if you multiply this, you will get z to the power of minus 2. That means the power of denominator is 2, and going to the numerator, the power is 1 here. So that means the value of numerator or the power m is 1 and n is equal to 2. So that means m is less than 1. We can apply the partial fraction directly. Therefore, x of z using partial fraction expansion. So we can write this x of z as k1 divided by, so the first term is 1 minus 1 by 2 z inverse, and the second term is 1 minus 1 by 4 z inverse. So let's find the values for k1 and k2. So k1 is equal to, so the denominator of that is 1 minus 1 by 2 z inverse into x of z, where z takes the value of psi l, that is 1 by 2 in this case. So now substitute that x of z here. Now x of z is 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus 1 by 4 z inverse. Z takes the value 1 by 2 here. So these two get cancelled. Will remain with 1 by 4 z inverse divided by 1 minus 1 by 4 z inverse, where z takes the value 1 by 2. Now if you apply this value, since it is z inverse, we have z is equal to 1 by 2, you'll get 1 by 4 into 2 divided by 1 minus 1 by 4 into 2. So this 2 and this get cancelled. So you get 1 by 2 divided by 1 minus 1 by 2. So that is 1 by 2 by 1 by 2. So value will be 1. So k1 value is 1 here. Coming to k2, so the denominator for k2 is 1 minus 1 by 4. So 1 minus 1 by 4 z inverse into x of z, where z takes the value of psi l. Here in place of psi l we have 1 by 4. So z takes the value 1 by 4 here. 1 minus 1 by 4 z inverse into 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse and 1 minus 1 by 4 z inverse. So these two value will get cancelled. So we'll remain with 1 by 4 z inverse divided by 1 minus 1 by 2 z inverse, where z takes the value 1 by 4. Now if you substitute that, 1 by 4 into 4 divided by 1 minus 1 by 2 into 4. So 2 times this, 4 get cancelled. So 1 divided by 1 minus 2 is there. That is 1 divided by minus 1. So you will get the value as minus 1 for k2. Now since we found the value for k1 and k2, our x of z is equal to 1 divided by 1 minus 1 by 2 z inverse minus, I can write plus, write minus 1 here, 1 minus 1 by 4 z inverse. Now we have to apply inverse transform. For applying inverse transform, we have to consider the ROC, which are three different ones. So first one, for ROC z greater than 1 by 2. So now if you observe, we have two things to converge, 1 by 2 and 1 by 4. But 1 by 2 is greater than 1 by 4. So if z is greater than 1 by 2, then it is obviously greater than 1 by 4. Now z greater than 1 by 2 means it exists outside the circle of radius 1 by 2 in z plane. Therefore, which exists means ROC. So ROC exists, or you can just write ROC here. Therefore, x of n is a positive time sequence. Looking at this, we have 1, and if you look 1 divided by 1 minus 1 by 2 z inverse, minus 1 divided by 1 minus 1 by 4 z inverse. Now if you take these coefficients 1 and minus 1 out, if you compare this, it is very similar to alpha n into u of n. So that means we can write in place of alpha we have 1 by 2. So the x of n is equal to 1 into 1 by 2 to the power of n into u of n. Why I have written u of n? Because it is positive time sequence. So u of n is present only for that. Plus, the coefficient is minus 1 here. So minus 1 into 1 by 4 to the power of n into u of n. Because if ROC is greater than 1 by 2, then it is obviously greater than 1 by 4. That is the reason. Okay. Or you can take the reference of 1 minus 1 by 2. Z inverse is in the form of 1 by 2n u of n. That is, so this is for the reference I have written. So therefore, we can write x of n for the first case as 1 by 2 to the power of n u of n minus 1 by 4 to the power of n into u of n. Now the second condition says ROC z less than 1 by 4. Now you have to imagine things here. It says we have two circles with radius 1 by 2 and another one with radius 1 by 4 in the z plane. So this is circle with radius 1 by 4 and this is circle with radius 1 by 2. Okay, this is just for illustration. Now this is 1 by 2 and this one is 1 by 4. Now the ROC is inside this circle. So that means if you go to the property of ROC, if it is a left negative time sequence, then only the ROC will be inside the circle. So that's why the sequence x of n is left-sided sequence or negative time sequence. So ROC is inside the circle of radius 1 by 4. Therefore, x of n is a negative time sequence. Now, taking inverse Z transform on both sides. So here I want to make one thing clear. If you observe for a negative time sequence, so for minus alpha n into u of minus n minus 1, you will get the same thing z divided by z minus alpha or z divided by z minus alpha as the z transform, but this will be less than alpha because this is a negative time sequence. Now we have to express this term x of z, this term, these two, as a negative time sequence. That means you have to multiply with u of minus n minus 1, which is the negative time sequence. So therefore, x of n is equal to, the coefficient is 1 here, so minus 1 into, in place of alpha we have 1 by 2 to the power of n, u of minus n minus 1, okay, plus this minus 1 is the value of k2, and 1 by 4 n is there, okay. This value is the minus value that we have to take, minus 1 by 4 n, okay. So or you just multiply this minus and into this minus, we can just write minus into minus plus here into u of minus n minus 1. Now this multiplies, minus and minus will get cancelled. So remember, with minus 1 by 2 n, u of minus n minus 1, minus into minus become plus 1 by 4 n, u of minus n minus 1. So this is the inverse Z transform for x of z, where the ROC is less than 1 by 4. Now taking the third case for ROC between 1 by 2 and 1 by 4. So here the ROC exists outside the circle of radius 1 by 4 and inside the circle of radius 1 by 2. So if you want to remember that pictorially, so we have two circles of radius 1 by 2 and 1 by 4 here in the z plane. Now this ROC is in between these two in this case. So the conclusion is, whatever the sequence, so x of n is a two-sided sequence. That means it includes both positive time sequence as well as negative time sequence. Now which one is positive and which one is negative? We have two factors there. If you observe this, now whatever it is greater than this 1 by 4, less than 1 by 2. Now whatever comes inside the circle, that part will be the negative. Whatever goes outside the circle, that part will be the positive time sequence. So based on this, whatever the term that are related to this first one, 1 minus 1 by 2 z inverse, that will be the negative time sequence because ROC is inside this circle, and 1 by 4 z inverse, ROC is outside this circle, that makes this as positive time sequence. So now we conclude this taking inverse z transform. So x of n is equal to minus 1. So this minus is for the signal because we have minus alpha n u of minus n minus 1, and another will be in the form of alpha n into u of n. These two are the combination of positive and negative time sequence. So that's why. So I'm writing minus 1 into 1 by 2 to the power of n u of minus n minus 1 plus the coefficient, that is the value of k2 into, so this is in the form, this is a positive time sequence, 1 by 4n into u of n. If you simplify that, you will get minus 1 by 2 to the power of n u of minus n minus 1 minus into plus is minus 1 by 4 to the power of n into u of n. So this is the inverse Z transform for x of z when the ROC lies in between those two circles. Okay, and I think I have not written ROC for the first case. If you want that, it will look like this. One is 1 by 4, another one is 1 by 2. Now ROC is greater than 1 by 2 means, so this is where it exists in the Z plane, 1 by 2, and this is 1 by 4. So now ROC is outside this circle, so therefore both of them are positive time sequence. In the second one is ROC is inside the uh, smaller radius circle, so that means it also comes under the radius of 1 by 2, so that's why both are negative time sequence. In this case, ROC is in between the circles, that means it is a two-sided sequence where the part where it is inside the circle is the negative one, and the circle where it is outside, that is the positive time sequence. So based on that, we have written the inverse transform. Now I will give you the table along with this handwritten copy. I will also give you the table of standard set transforms, which will be easy for you to uh, remember the standard set transforms of the signal, like x of alpha n into of n when it is positive and when it is negative time sequence, and its ROC based on that. That will be for your reference. I'm going to upload that for you. Okay. Hope you have understood this partial fraction expansion method, and I will take some more examples in the next video. Now before going to that, uh, I will give you a problem for you to try using partial fraction expansion. So first one is, given x of z is equal to 1 minus 3z inverse. Actually it is given in this way, z square minus 3z divided by z square plus 3 by 2 z minus 1, where the ROC is in between 2 and 1 by 2. So here first step what you have to do means, you have to eliminate the first term to 1. So you have to divide both the numerator and the denominator by z square. So you will get x of z as 1 minus 3z inverse, because a naught should be 1, so that is the reason, and 1 plus 3 by 2 z inverse minus z to the power of minus 2. Now if you look at this, we have 1 and we have 2 here, so obviously the power of numerator is less than the denominator. For this one, next step is you have to find the factor for this, and you can apply the partial fraction expansion. Okay, so try this and try to get the solution for that one, and I will give you the answer as well for your verification. You should get x of z as I'll give you the final answer, x of n uh, minus 2 to the power of n u of minus n minus 1 minus 1 by 2 to the power of n into u of n. Y means you can see this, we have z lying between 1 by 2 and 2, which is a two-sided sequence. So you can try this one, and I'll give you one more problem. You can apply this. Given x of z is equal to z divided by 2z square minus 3z plus 1, where z is less than 1 by 2, and I want you to try one more here. X of z is equal to 2z cube minus 5z square plus z plus 3 divided by z minus 1 and z minus 2. So as you multiply the denominator, you will get the powers in positive. So you repeat the same step that I have done here for this problem, for problem number 3, and afterwards you can follow the further steps. Okay, so this I will give you the solution as well in the next video, and I want you to try these problems on your own. So these are the few examples that I am giving you to try. Try to get the solution for this. One is a negative time sequence, and this is also negative time, and this one is a two-sided sequence, and this one is a positive time, and this one is a positive time sequence as well. So try to get the result for this. In the next video, I will give you the solution for this, what is the final answer, and I hope you will get the solution for all 5 of them. If you have any difficulties finding the result, do reply to this video, and you can comment also. Okay, thank you for your time.